Keep it on the same time limit, next thing word. Okay, you got a finish. Yeah, work on this out now.
Oh, wonder if I can.
Then I don't know why you came back in here. And then you want to get back in there too. Yes, ma'am, so how? No, you can just wait. No. You can just work on. You want to put a little no straw. All right, let's go. 8 and 2, consider the number line and say which point best represents the value of square root of 60. What about keyword and information? Best represents. And dealing with squares, think of perfect squares. What perfect squares?
Oh, what? Alright, your pencil should be moving, because mine moving.
So anytime I deal with square roots, I always think of perfect squares. Case in point, 2 squared is equal to what? 2 squared. 2 times 2. So that means the square root of 4 is a perfect square. That would mean what's multiplied together. So 3 squared would be. So y'all 3 times 3?
So 3 squares like 60 times 60.
3 times 3.
I mean 60.
We ain't worried about that. We ain't made it over there yet. Right now, we only doing this. So you can't do this. We can't comprehend that.
So like 4 squares, that's what it
4 squared gonna be what? 5 squared. 6 squared. 7 squared. 8 squared.
60.
9 squared. So if you know your squares, you can easily dissect or determine between what numbers it'll lie. So looking at the square root of 60, between what perfect squares would it fall? Eight and 10. Between 8 and 7, or would you say 7 and 8? Which came first? Okay. So now looking at that, 7 was 49 and 8 is 64. So would 60 be closer to 7 or would it be closer to 8? 8. It'd be closer to 8. So based on that notion, what would be our answer? K. Why we say K?
Also the 10. No.
What does that little mark tell me? Oh, thank you, baby. Half. But yeah, part 2 is okay. But that little mark represented half. So if we said that the square root of 60 is closer than 8, common sense would tell me I need to be on the other side of 5. Questions on? You need it, definitely need anything that you need. Those Thursday math days, I'm all over math. All right, the second question. which number line best represents the values of square root of 38 and the square root of 53? So once again, we ain't gonna rephrase the real because we already got our squares. Which one was it? 38 or 53? On the other side, 38. So looking at 38. Between what perfect squares would 38 fall?
38.
Five,
No. 38.
5 and 6 is 25 and 36. Between 6 and 7. So then we'll ask ourselves, would that 38 be closer to the 6 or would it be closer to the 7?
6.
Is 38 closer to 36 or is it closer to 49?
36.
Yeah, for my people who couldn't comprehend what I meant by that notion. Closer to 36. So with that notion, we know that our answer is gonna be close to which one? 6. Which one you say?
Yeah, it's like, yeah, the 53.
All right, so look at 53. So between which two would 53 fall?
7 and 8.
7 and 8. So would 53 be closer to 49 or would it be closer to 64?
49.
So it'll be closer to 7. So we got one that should be closer to 6, and then we got the other one that should be closer to 7.
I think it's deep.
No, you ain't got to wrong. You can just put the correct one after we get the correct one. B or D? What's her name? D.
Deep.
D as in dog?
Yes.
Square root of 38, because 106 would have been 36. That would have been 49, and then of course that would have been 64. Good job, D. Questions on? Anytime we see square roots, we ready to pick up calculator. But if you want this easy approach, we'll never need to touch the calculator. But the fluid degree after this, so afterwards you just slide that on your chair. I pay for a piece of the thing. Need if we. Put everything up on top of your desk. Slide it on. When you bring your paper, make sure you go to minute 3. Put your name, date, and then put your pencil down. Minute 3, go ahead and put name, space, date. The way we think, we all ready. Pencil down, so I know when to fill up the top. Yep.
Oh, it's starting.
Well, you know what? But you get the same opportunity. All right, ready? All right, you can go. Remember, if you stuck, skip it. Come back to what it's got to mind. Did I get my word? Did those that had it, did I get on? I will just say that, keep on. All right, pencil down. Slide around. All right, number one, talk to me.
5 plus 8 gives 32, 35, 2 gives.
All right, rewrite, 4 times 4 times 6 times 4 times 4 times 6. What we got?
I put 4 to the 4th power times 6 to the 2 power.
Yes, make sure they got multiplication symbol in there, not just 4 to the 4 and 6 to the what, it need to be multiplied, this dot, or they got the multiplication symbol. Number 3, talk to us.
So when I did it all together, it gave me 21 over 9. So,
I'm slow,
huh?
I'm slow.
Oh, so you had to do 3 times 4 equals 12, and then do 3 times 6, 3 times 2 6. and then
No.
add-
Okay, distributive property in parentheses, okay, so now 18 divided by 9. Brad thinks that 2 times 2 times 2 times 2 is 4 squared, what's wrong?
2.
They multiplied it one time, and they multiplied it 2 times 2, and then after that, they changed it to make it 4 times 4.
The base is 2.
They changed the base.
No, that's, okay, cause yeah, your word and all out. Now that's the base, but what else is wrong?
That's probably 2 more times instead of 14 times.
So what's wrong?
The phone is supposed to be there, the base supposed to be.
That part. So as long as they interchange the base and the exponent, or they had it backwards, the 2 and the 4 should be in a different spot. I'm gonna let you kind of judge that. All right, number 5 is the 8th grade standard scientific notation. That exponent tells you how many times to shift. Since it's positive, we're gonna shift to the right. So check your decimal and shift 3 times to the right. 1, 2, 3. What do we end up with? 3,200. 3,200. They had 32,000? Okay, now I'm about to say they must count to 0, but on the shift. A is 2, B is 3, what does AB equal? So that would be 2 times 3 squared.
That's going into 2 times 3 is 6.
No, sir, that is how it is.
3 times 3,
And then 9 times 2.
18.
So when they give you exponents, pay attention to which one has the exponent. In this instance, B is the only one that's squared. Had they put A, B in parentheses, then with a square, then we will multiply them together first, then squared. But definitely pay attention to where's your exponent. All right, number 7 gonna work just like 5. What do we end up with? Exponent of 3, we shifting 3 times, shift on that paper if you need to. 1, 2, 3, what do we end up with?
4.3.
Did you shift on your paper? You got 4.3? Is your decimal between your 4 and your 3? Where's our decimal now?
Behind the 3.
So what's our number? 43, it's at the end, so that means everything in the front is our number, 43. A mouse got 14 whiskers, how many whiskers does 3 mice have?
42.
Talk to me, what you did?
14 times
You did 14 times 3, or you could have added 14 3 times. However you see fit, should have gave you 42. All right, number 9, talk to me.
9 times 6 give you 54. 54 plus 5. 59. 59 minus 4 give you 55.
Good job. Which of these operations should be completed last when solving an equation?
Division.
Addition.
Pendants stand for what? Parentheses.
Exponents.
Multiplication.
Multiply and divide go together, so you gotta read it together. So parentheses, exponent,
Multiplication.
multiply and divide,
Addition.
add and subtract. They go together. So what's our last one? Add and subtract. Count the ones they got correct. Put that on top and add a 0 behind it. So if it's 4 that's not crossed out, the score will be a 4. Put the score up top, slide it back to its owner, pull back out your bell ring up. I'll take it. You don't got this one, She can give you an credit for it. So with it. All right, put it down the bell ring notes, your math notes, you can add to the bottom of your bell ring notes, or you can add it on the steps of your paper. You should have a math binder or a notebook with something that you keep up with the stuff in class. Now, we pick up our papers, put them in our bin down now.
Can I add my credit to you? Huh? Can I add credit to you?
No, that ain't what it's gonna run. That's fluency and dealing with a TST truck. Today we're gonna be rational and irrational numbers. Rational and irrational numbers. You yapping. Your paper ain't big out. Come on. The last short there, he took y'all.
They keep putting that stuff in our bill.
I just put them in there, because they're your absentee. Don't nobody have it. I said, well, they got your bell word. We put it on the end of your bell word. Or you can get a simple page. So we're gonna review rational and irrational numbers. Some of this vocabulary you should have, because Maxwell said she gave it to you, but if not, we definitely need to know that a rational number is anything that can be written as a fraction. If you need these examples, you can get them. If you need the definition, get the definition, but you should have it from Maxwell, but if not, you need to know it. So a rational number is any number that can be written as a fraction. The first type of rational number is a whole number. Those are zeros and count numbers. When you start to count, what do you count with? 1. So take everything I count with and add 0 in the front, it's a whole number. Natural numbers are our counting numbers. And what did you just say we started counting with? 1. So 1 and everything above, that's a whole number. It's natural. Meaning it's gonna be what kind of number?
A natural number.
And a natural number is a
Real number.
what kind of real number?
Oh.
Before I get to real, it's rational.
She said natural.
We just said that. Natural number is a rational number, which makes it a real number. We're just going through examples of all your rationals. So if you don't know these rational numbers, you might want to give them. The next type of rational is integers. We should know integers are whole numbers and the opposites, positive and negative numbers. Fractions are rationals. Terminating decimals, those are our decimals that stop. And then repeating decimals, decimals with repeating digits. Somebody give me an example of a repeating decimal.
0.3 with the ball.
If I say repeat, and don't give me talking about something about the bar. Thank you. We'll take that. So I'm gonna move down and I'm gonna show you the difference. Because I don't want you to confuse a repeating decimal as irrational. Somebody last like that, everything that repeats is irrational. I said, no, it's not, and I hope it's Maxwell didn't teach me. Then, of course, the last thing that's rational, those perfect squares and cubes, some that we just looked at for bell work. Irrational. Irrational is any number that cannot be written as a fraction. And these are examples of all irrational. symbols, anytime that number got a power symbol, it's rational.
On words A, words in Q, on words A, is that a rational type?
It's a little three. With the little three.
So basically, anytime we see that it's rational,
Yeah. Anytime it has to be perfect, meaning the answer is gonna be a whole number. I know cube root of 8 is gonna be 2. That's a whole number. Compared to if I had the cube root of 10, that'll be 2 point whatever, whatever. With it being 2 point whatever, this would make it irrational. Because this is square root, this got a whole bunch of numbers around it. So that's why I said, make sure we know the difference between those that are perfect, gonna give you a whole number, and those that's gonna give you some stuff with it. So if you get some stuff with it, it's gonna make it irrational. Other type of irrational is non-terminating and non-repeating. That's another one that a lot of us confuse. Non-terminating and non-repeating is a decimal that you see where it has a whole lot of numbers behind it. It don't go in any specific pattern, it's just a whole lot of numbers behind it. And those are irrational. So notice the difference. If it repeats in a certain order, it's gonna be rational. If it don't repeat in a certain order, it's gonna be what? Irrational. And we just discussed those squares and cubes that are not perfect. This is another example up here of what we mean by irrational. It's not a perfect. And what we mean by perfect is, like I said, if you were to put it in a calculator, it won't give you a whole number. All right, and then of course, real numbers make up all numbers. All rational and all irrational are all real. Any questions? Kind of remember from when Max gave it to you a little bit? All right, the next piece we're gonna look at. How to change repeated decimals to fractions. Did it match what you did? No. Did she teach it to you? Or she told you to put some letters in the calculator? So that's the difference, right? All right, so let's look at how to change a repeated decimal to a fraction. The first thing it told us to do is to do what? Last decimal place. Looking at these numbers here, what's our last decimal place? What's the last decimal place? I didn't say the digit. Place. 2 places after the decimal is tens. You an 8th grader telling me 2 places after the decimal is tens.
hundreds.
Thank you. Now you can't even tell us what's our last place. You gonna be failing this. So I hope your pencil moving. Everybody's pencil need to be moving with this problem. So our last place will be 100. So I'm gonna go ahead and put 100 as my denominator. What did the second step tell us? Well, that was to help y'all remember what place is what. Skip down to number 2.
Subtract 1 from the denominator.
All right, so notice the difference. It stopped at the hundreds place. Go ahead and put that as your denominator. And then it told us to subtract 1. We are subtracting 1 because it repeats. When it's all the time, we're gonna subtract 1. When it repeats. So we're gonna subtract 1 from this denominator, and what we end up getting. And what number did we have that repeats? Just a 4? All of it. So our answer would be 74 over 99. Somebody give me a number. So if I had 0.7 repeat, it's the 10th place, so I'm gonna go ahead and put my 10, but since it repeats, what do I need to do?
Any class that has not been to lunch, you may do so at this time. Any class that has not been to lunch, you may do so at this
All
time.
right, we subtract, what do we end up with? And what number do we start with? So 0.7 repeats, it's the same as 79. Did I lose you or confuse you? All right, So we reviewed a little bit of rational, irrational, the examples of each, and then we reviewed how to change the fraction to a decimal. And then I tell them, if all else fail and you couldn't remember, play the calculator. But if they don't give you no answer choices, it be kind of tricky with trying to determine which one will work. All right, we're gonna practice on, go to page 13 and 14. There's your map, don't see what we get. Definitely know we're gonna use it on what today.
Thursday and Tuesday.
All right, if you get a point on my board over there in the green, below 8th grade, somebody can read it, tell us what it says. I'm the one in the green.
Hey, 13, 14, 38.
All right, circle those problems that he mentioned, 22 through 38. I put them on top of the page, or you can turn the page out and circle 22 through 38. And we're gonna look at numbers 22 and through 38. Which is also your homework. You got some time right now, you can go ahead and get started. Anybody have homework for last night?
Yeah, that's both of me at one time.
Tomorrow you got vocab quiz from last week. Let me know when you're ready again.
So Ms. Kitchens, how do we do it if they not like, if they don't continue?
If they don't meet, then you write them like you know in the rules from 5th grade, whatever their denominator